All right, let's have a look at the variations. First question is LeetCode question number 3. Longest substring without repeating characters. Difficulty level medium. Given a string, find the length of the longest substring without repeating characters. Comes with 3 examples. Input ABC, ABC, BB. Output 3 with the explanation that the longest is ABC with the length of 3. Example 2, and we see like 5 B's and an output 1. Says the answer is B with the length of 1 because there's a lot of repeating characters. Then we got like example 3, P, W, W, K, E, W. Output 3 with the answer W, K, E and the length of 3. Note that the answer must be a substring, it says here. PWKE is a subsequence and not a substring. So the next one is 86, partition list. Given a linked list and a value x, partition it such that all nodes less than x come before nodes greater than or equal to x. You should preserve the original relative order of the nodes in each of the 2 partitions. Comes with 1 example. Head equals 1, then points to 4, 3, 2, 5 points to 2, and we want x equals 3. And then the output is reordered in the following: 1, 2, 2, 4, 3, 5. Next one, linked list cycle. Given a linked list, determine if it has a cycle in it. The cycle is explained below in the drawings as well. To represent a cycle in the given linked list, we use integer pos, which represents the position 0 indexed in the linked list where the tail connects to. If pos is equals to -1, then that means there's no cycle in the linked list. And then in the first example, we see a cycle where -4 points back to 2. And then the position basically is the first position in the linked list. So we have head equals 3, 2, 0, -4, and position is 1, and the output is true. There is a cycle in the linked list where the tail connects to the second node. Example 2, head equals 1, 2, position 0, output true. There is a cycle in the linked list where tail connects to the first node. Example 3, head equals 1, position -1, output false because there's no cycle in the linked list. Number 3, reverse vowels of a string. That's problem 345, reverse vowels of a string. Easy. Write a function that takes a string as input and reverse only the vowels of a string. Input hello, output holly. Example 2, input LeetCode, output Leotseed. So we see that the order is basically completely reversed for the vowels. Note the vowels do not include the letter Y. And the last one, trapping rainwater with the difficulty of heart. Given n non-negative integers representing n elevation map, where the width of each bar is 1, compute how much water it is able to trap after raining. The above elevation map is represented by the array 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, 1. And the blue section basically denotes the trapped water. And then the example is output 6, is basically the summation of all those areas where the water can be trapped. So the main theme is called the 2 pointers technique. And the best description for that theme can actually be found by the website Geeks for Geeks, the computer science portal for geeks. It has a very concise description of the underlying theme, and let's go through it step by step such that we understand how to best use it. So what they say is 2 pointers is really an easy and effective technique, which is typically used for searching pairs in a sorted array. So the underlying problem always something like, given a sorted array A in an order, ascending order, having n integers, find if there exists any pair of elements A, I, and A, J, such that their sum is equal to x, for example. So then they come up with a standard solution where you basically iterate over all different combinations of 2 indices, which is just like x squared or like n squared over the array of size n, which is just like very complex, O of n squared. And then the 2-pointer technique is outlined here. They say we take 2 pointers, one representing the first element and the other representing the last element of the array, and then we add the values and keep both pointers. If their sum is smaller, then we shift the left pointer. If their sum is greater, then we shift the right pointer. And note again that that only works if the array is sorted, right? If we have basically some underlying sorting going on already in that array. So we would implicitly know if our target is too small, we would have to adjust from one end, and if our target is too large, we have to adjust on the other end. And then the termination criterion is basically either they meet or they go across each other. And the other termination criterion is like we have found the condition or the sum that we want to achieve or fulfill. Let's have a look at their example here. 2-pointer techniques based solution to find if there's a pair with a given sum. Bool is pair sum with the array, and then the array size, and then the sum that they want to achieve. Go straight forward, and that basically has the exact solution. So with that in mind, now let's have a look at the individual solutions to the 5 problems that we were looking at the very beginning, and find their individual variations of the underlying theme that we can use 2 pointers for solving the problem. So let's remember the first problem was find the longest substring without repeating characters. And here we basically have 2 iterators or 2 pointers denoted here as string iterators. So we have like an iterator left, which is at the very beginning of the string, and then we have a loop where we basically go from the current left position all the way to the end, and find a position where we find the letter at that iterator position again, starting from left all the way to the end. And then if that letter is only the starting letter, we have to adjust in the following. We have another if condition, and then we find out if we have like a new maximum for that longest substring. If that's the case, then we denote the number of maximum. If the position is somewhere else, then that means we can move over to that position. So that means like we adjust our left straight all the way to that position that we found here in that line. Autopause equals find from left to the range of iterator. And then basically we do this up until our iterator has solved all the way to the end. And once we have solved to the end, we are sure that since we kept track of the maximum length from it to left +1, so that's basically the range, we kept track here in this condition. So that means that once the for loop is finished, we can return maximum, and that's actually the maximum value. And here the identification is that we have the pointer left, and then we have the pointer it. That's basically updated automatically. Okay, the next one was the one where we want to partition a list. And also in here we see like 2 pointers. So we have a left pointer and a right pointer. And we make sure that the left pointer basically gets assigned the first valid value from the head. And then the second pointer is if a pointer exists for temp1, then it's temp1, otherwise it's head. And then we basically just go through all the way up until we still have pointers in the second pointer and has a child in the second pointer. And then we check if that value is smaller than the target value or if that's not the case. And then if that's the case, we go in here and check if we need to rearrange the list. In that case we do. Or we append the list. And then we do that all the way up until the second pointer has basically reached the end. And the first pointer gets updated accordingly within the logic inside the loop whenever we need to adjust. So again here, a solution for the partition being neatly achieved by using 2 pointers. So the next technique is, I think, the most prominent for just using 2 pointers, and that is the one where we want to find out a cycle. And the idea is basically have 2 pointers with different speeds, so we call them a slow pointer and a fast pointer. The slow pointer goes by speed 1 and the fast pointer goes by speed 2, which, like in terms of like numbers, can be thought of like a modulo. And if there's a loop, then the modulo 1 and the modulo 2 should meet at one point, because one is fast, one is slow. If there's no loop, then the fast pointer goes to the end, and then the slow pointer at one point goes to the end as well. But if the fast pointer reaches the end first and then we're done, then we will know this as a return false. So let's quickly dive in here. While the fast pointer is still valid and has a child or points to like a next valid node, so that means while we're still like in some sort of path within the graph, we update the slow pointer by 1 and we update the fast pointer by 2. Next. And if at any point in that iteration we find that the slow pointer and the fast pointer meet, which is never the case once we have left the head, and never the case once we have left the head and have no cycles in there, then we know that there's no cycles. But if slow pointer and fast pointer meet after we have left the head, then that means the fast pointer has gotten stuck in some sort of cycle and has met again with the slow pointer, and that means that satisfies the condition that we have found a cycle. Okay, the next one is where we reverse the vowels. So first is of course like some sort of helper function where we just check if we have an uppercase or lowercase occurrence of a vowel, A, E, I, O, O. And the reverse vowel basically really just goes with a left pointer and a right pointer. We iterate up until like the pointers meet, which is like a nice termination condition for 2 pointer solutions, that like we start on both ends of the array, and then we go, and then once they have crossed each other, we know that we kind of like went through the array completely. And then we just go along, right? So I starts at the left end, J starts at the right end, and while they have met and while one pointer has not reached the other end, we check if there's a vowel condition or not. If it's not a vowel, we continue. If it's a vowel, we do that swapping, and swap is basically a standard implementation of just taking one value, temp value, assign that value to the temp, assign the third value to the first one, and then assign temp to the other. And once we have did this, once we have done the swapping, we basically update both pointers, because then there was an occurrence where we have changed the vowels. Then basically there has been an operation performed at these 2 positions in the array, and we need to like go to the next one. So that's the two-pointer solution for doing vowel swaps. So the last one is about the height. How much height can we swap? And here the solution is also like kind of a neat and concise one, where we basically just keep track of like some sort of maximum left height and maximum right height. And whenever there's like a larger maximum height, we know that this kind of can store more water. If there's a smaller height, then we know this is like the smaller amount of water that can be stored. And if we go from a larger array to a smaller subarray, we can always keep track like what was the maximum amount from here to here, and if go smaller, do I get more amount or less amount? If I get more amount, then I update that amount of value that I get within that range. In our case, that value is the value of a height. So we query those heights with the like looking into the array and querying it with the height and storing that value, right? So we do this again up until our termination criterion is one pointer has met the other pointer, and we go along by just like keeping track of which one is the maximum height left and right, and saying so Lmax equals the current maximum of the current height and Lmax, and Rmax equals the maximum of the current height of J and Rmax. If the left maximum is smaller or equal than the right maximum, then we add this to the total amount that we tally and that we initialize with 0. So it's like total plus equals the difference of the left maximum height and the current height that we are looking at with the pointer, and then we are updating that pointer. And in the other case, we basically say if the right maximum is smaller than the left maximum, then we look at the right maximum and the height of J. So basically I compare that part for the current water storage, and we compare that part for the current water storage, and whatever maximum is bigger than the other maximum, that's the one that we use for the subarray that we use for comparing the values, and then summing this value up in the total. And whichever one we used, we need to update the pointer there, because then this case or this like subarray has been accounted for already. And then once we iterate this way through the whole array, we keep tallying all those different heights into our total. And once those pointers met, we are sure that we have basically accounted for all those different arrays.